So in this activity, we're going to look at additional Delta Math problems, which is Unit 6 and our transformation. In the first few problems, the B value is given as 1. We'll talk more about that as we go through this first set of problems. So the far right number here, which I'm going to call that the D value, the subtraction problem. We add that in, that'll be the C value. That's the midline. So the midline splits the graph in half. So the midline will be at -2. The first number is the amplitude. So how much are we going up and down from the midline? And that is 2. The reason why the B value is 1 is that as a sine graph which crosses at 0, the period is 2 pi. If I look at the sine graph starting on the y-axis at 0, and the 0 would be actually where the midline is, and if I would draw out one period, the length of that period is also 2 pi. So in both graphs, the graph has not been stretched left or right. So keep in mind that the B value times the period, which the period here is from here to here, is 2 pi. 2 pi is supposed to equal 2 pi. So the B value has to be 1, because 1 times 2 pi is 2 pi. In problem number 2, we have a cosine graph, and that's the dark graph, or the one that's not dashed. So we're trying to write the equation for the graph that is dashed. So the midline would also be at -2. That would be this number here. First number, again, is the amplitude, how much are we going up, how much are we going down from the midline, and that is 2. So this will be the equation for this dotted graph. Again, the B value is 1, and the reason why is because if I look at a cosine graph, the cosine graph has a period of 2 pi, or 360 degrees. If I look at the period for the cosine graph, that's the dashed graph, and on the y-axis it's going to be, in this case, 2. Above the midline, that's where we're starting. And if I go complete period, it's also 360 degrees. So both graphs have a period of 2 pi, or 360. Just like problem 1, B times P is equal to 2 pi. The period is 2 pi, or 360. And looking for the B value, that's times 2 pi gives me 2 pi, so B is going to be 1. That's why this number here is 1. In problem 3, the midline, so the value that cuts the graph, the dash graph in half, so the midline is at -1. Amplitude is how much we're going up and down from the midline, which happens to be again 2. This is a very popular answer here. And the B value again is 1. So we're at a sine graph, so we're starting at 0. So the new 0, when we slide the graph down to the midline to -1, that new 0 basically is at -1 instead of at 0, 0. And if I would graph one period of sine, would go from 0 to 2 pi. If I would graph one period of the other graph, it's also 2 pi. They're both 2 pi, which means the B value, again, does not change as a value of 1, for the same reason that I mentioned for the last 2 problems. Since the period is 2 pi, and then for B it has to be 1, since 1 times 2 pi equals 2 pi. So in problem number 4, the graph's a cosine graph, again starting at 1 on the y-axis. So for the graph that we are trying to change it to this dashed graph, the midline is at 0. The amplitude is at 5. We are 5 above and 5 below the midline. So keep in mind that wherever you select the midline to be, the amplitude should be the same amount going both directions. The cosine period is 2 pi, or 360. And then the cosine graphs also start on the y-axis, just happens to be at 5 instead of 1. And if I would show a period for this graph, it is also at 360 degrees, or 2 pi. This is the reason why, again, the b value is 1. Alright, so problem 5 and 6 is asking the question, why is the b value always 1 for the problems 1 through 4? Hopefully I've addressed that well enough. You can answer that question if you have not. Or if you have an incorrect answer, please change it. And then describe the change in the graph if the b value changed to 2. What happens if the graph the b changed to 2? How's the graph going to be changed? Start with the counting issue or error, so there is no problem 7. Starting in problem 8, you'll notice that the b value is no longer mentioned as 1, so this time we're going to figure it out. So starting with the midline, so the top is at 0, the bottom is at -4, so the midline will be at -2. The amplitudes, how much we're going up and down from the midline, so we're going up and down 2. That's the amplitude. For the b value, keep in mind we're doing b times the period has to equal 2 pi. So for the original graph, the period for a sine graph is always 2 pi. That's why, again, the equation ends with 2 pi. For this graph, again, our 0 is actually starting at -2 because the graph hasn't moved left or right any. And a period is 2 pi over 5. So we need to figure out what b value do we multiply to 2 pi over 5 to get 2 pi. So a couple ways of doing this. I'm going to use the reciprocals. If I multiply both sides by the reciprocal, the 5's cancel out, the 2 pi's cancel out. So on the left side, all I have left is b. On the right side, the 2's and the pi's cancel out, so the only thing that's left is 5. So the b value of this problem is 5. Now, further on, so the first period went from 0 to 2 pi over 5. If I do the next period, it would go to 4 pi over 5. It's the third period. Fourth period. And fifth period. So I want you to see that our answer B, 5, represents how many periods will occur in our transformed graph when compared to the actual parent graph. It takes 5 of them to get to the full length of 2 pi. So going back to that question number 6, when I asked the question, you changed the b value from 1 to 2, how does the graph change? Did you answer that correctly? All right, problem 9. This is a sine graph. So again, we're starting at 0 on the y-axis. and we're doing a full, or doing 360 or 2 pi. This time, the graph should also start at the y-axis. So you'll identify that place for the midline first. So the top of the graph's at 2, the bottom of the graph's at -4, so the midline is at -1. The amplitude, so we're going up 3 and we're going down 3. And the graph itself, again, starting on the y-axis, just telling this graph isn't being shifted, because in both cases the graph's going up. Sometimes the graph can intersect the y-axis and actually the sign will be going down. So that means the graph has been shifted or flipped over. In this case, they're both going up, so we're good. And so for sine, full period would be 180 degrees. So in this problem here, the period is pi, 180 degrees. I need to be 2 pi. So B has to be 2. 2 times pi is equal to 2 pi. That's the B value. Which means that if I would do another second period, I should get to 360, which I did. Oops, 2 pi. Should stop here. So that 2 is representing how many times that graph will cover the full 360 or 2 pi. All right, so this problem here, the top of the graph's at 4, the bottom's at -2. So that means the midline is at 1. The amplitude is 3. And then the B value, again, a full period for cosine is 360 or 2 pi. So we are starting at 1 around the y-axis, and we're doing a full period, which is 60 degrees. All right, so for the B value, I'm going to use pi over 3, since that is the radian measurement for 60 degrees, which is our length for one period. So B times pi over 3 has to equal 2 pi. So I'll multiply both sides by 3 over pi. And so the pi's cancel each other out, the 3's cancel each other out, so on the left side all I have left is B. On the right side, the pi's cancel each other out, so what I have left is 2 times 3, which is 6. The B value is 6. So, if I start here and go to the second period, it's 2, 3, 4, 5, and 6. I'll stop the video here because we're running out of time on the first video, so we will continue with problem 11 in the next video.